Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I am Jeetendra Dixit. So here is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. Let me check my voice first. Yes, perfect. Okay. So we were doing indeterminate forms. I'll continue indeterminate forms in this. In previous session, we have done infinity by infinity and standard forms. Today we'll continue infinity minus infinity form. We'll discuss infinity minus infinity and 1 raised to infinity, right? But before we begin, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and you can subscribe on Plus as well as Iconic. Two types of subscriptions are there. Raghav, yeah, this if you have seen my previous sessions, so it was detailed, and today also it will be detailed. Infinity minus infinity and 1 raised to infinity. All right. So yeah, I was telling you about the Unacademy subscription. As you know, Plus subscription you can take. If you get Plus subscription, you can get access to daily live classes of all the educators who are teaching on Plus. You can watch their live sessions as well as recorded sessions. So if you miss something, you can watch recorded sessions offline by downloading them. You can ask your doubts during the live sessions only. Then thank you, Raghav. Where are you from? Live tests and quizzes will also be accessible to you. All these courses are well structured. And have you done limits, or are you doing it for the first time, Raghav? Kimka. Oh, Lucknow. Very nice. I was teaching in Lucknow long back, few years back basically. This is the unlimited access you get once you subscribe for the channel. Once you subscribe on Plus. Okay, Raghav. Then you can watch. Then you can practice with me, infinity minus infinity and for 1 raised to infinity today. This is 12 months. You can buy 38,500 and 24 months. It is 56,000 and you'll get 10% discount. Use my code Jeet1 to get 10% discount. All right. And the second is Iconic subscription. So Iconic subscription, you get all the benefits of Plus, and apart from that, you get a personal coach who will guide you throughout your preparation for top exams. Your test analysis will be done in a personalized manner. Personalized feedback will be given to you to improve your time management and exam approach. And similarly, study planner will also be customized. All right. 1 minute. So this is Iconic subscription. You get 1 minute, guys. So can I still excel in maths for the JEE Advanced? I have prepared most of the physics and chemistry, but lagging in maths. Maths requires practice. If you haven't done it before, then do it now. Give more time to maths than physics and chemistry if you have already done physics and chemistry properly. But keep practicing physics also and chemistry. But yes, you can. Certainly you can. But you'll have to do a lot of work. Practice basically. Yeah. So all the benefits and plus. So this is Iconic subscription. You can buy 1 year and 2 years plus subscription, Iconic subscription, in 56,000 and 86,000 respectively, and you get 10% discount using my code Jeet1. All right. You can download this Unacademy's learning app from Play Store. and then start attending special classes at least. So you can attend special classes on Unacademy. No, they are completely free. You don't need to take any subscription for that. Like I also take special classes generally at 8:30 for doubt classes of mathematics. So you can come and join there in my doubt class. Today I don't have, but tomorrow I'll be having a doubt class. Sir, I have taught functions too. I'm already a plus member, sir. All right. You're already plus member and very, very, very nice. I have not taught functions, everything in functions, but yes, you can watch my videos of functions in which I have covered onto into functions in detail, and with basically a lot of good questions of onto into functions mapping basically. And now I've also done range questions based on range and domain. Okay, so three topics I have covered in functions before limits, so you can watch those videos. All right. That much I have taught in functions. Yes, I have taught. So I've taught basically how to find domain, how to find range, all the methods of range I have taught. Okay, so you will find those videos. Just go to the list and you will get all those videos. All right. Okay, so let's do infinity minus infinity today. Complex number. Yes, I'm doing complex numbers. In complex numbers at 3 o'clock. Today also I taught rotation at 3 p.m. and before that I have covered nth roots of unity and cube roots of unity, theory of this, and I've taken one practice session of complex numbers, and tomorrow I'll be taking geometry of complex numbers. Okay, theory. So geometry I'll be doing. I've already taken practice sessions before, and now I'm covering theory also. You will get you can see you know how to see the complete list. So, if you're watching my video, then you can go to the complete list. So, if you click on the title, continuity, there's a tab. So you will get a list below the video, in which you can see there will be watch the full playlist here link. So click on that. You can see all my videos. All right. All right. So next is infinity minus infinity form. Right. So in infinity minus infinity form, what you do basically you club both the terms by simplifying. Mostly it is like algebraic minus algebraic form. So let's take one example. Ultimately, we convert this infinity minus infinity form by clubbing two terms in either infinity upon infinity form or 0 by 0 form. Okay. Let me give you one example. Like you have written x raised to 2 2x square minus 3x plus 1, okay, minus under root of, say, 2x square minus plus 3x minus 1. All right, divide, x is approaching to infinity. Yeah, that's it. So this is the sum. This is one example of infinity minus infinity. You can see first term is approaching to infinity and second term is also approaching to infinity. So there's nothing new in infinity minus infinity form. You just need to simplify this, and after simplifying it will be infinity upon infinity or 0 by 0 form. Okay, so in these two forms you can convert this. So see this one, if I rationalize it, you will get this 2x square minus 3x plus 1, and minus of it is going to be 2x square plus 3x minus 1. All right, divided by it is going to be under root of 2x square minus 3x plus 1 plus, it will be plus now, so plus of 2x square plus 3x minus 1. All right, like this. X is approaching to infinity. Okay, now this is the form. After this, now you can see I think you have got this step. I have multiplied and divided by this term, under root of 2x square minus 3x plus 1 plus of under root of 2x square. Okay, so in numerator it is now a minus b into a plus b, so a square minus b square. Now 2x square will get cancelled, right, and add the remaining terms. So it is going to be minus 3x, then this is 1 plus 1 is 2. All right, divided by all these terms are as it is. So there's 2x square minus 3x plus 1 plus under root of 2x square plus 3x minus 1. All right, now it is x approaching to infinity. Limit. Now it is infinity by infinity form. You can see that, right? Infinity by infinity form. So in infinity by infinity form, as I told you yesterday, you can take take the highest degree term from numerator and denominator common. So you can see x is the highest order term here, and from denominator you need to take x square common from square root, and outside it will be x only. Okay, so if you take x common, it is going to be minus 3 plus 2 upon x. Okay, this 2 upon x will become 0 when you put the limit, and take x square and x square common from these two terms as well. So x will come out, and it is going to be root over 2 minus 3 upon x plus 1 upon x square plus under root of 2 plus 3 upon x minus 1 upon x square, like this. All right, this x and x will get cancelled, so limit of x approaching to infinity. Now if you put the limit, so it is going to be minus 3 in numerator, because this term will be approach to 0. Similarly, these two will approach to 0, these two will approach to 0, right? So it is going to be root 2 plus root 2. All right, so it is going to be 2 root 2, 2 root 2, 2 root 2. So yes, that is the answer, minus 3 upon 2 root 2. All right, I hope you understood. Got it? Okay, now I'll give you one example to solve. Now you guys try it. Hello Vamsi. X is approaching to minus infinity. Now it is minus infinity. Okay, be careful. And in numerator it is x square plus x plus 1 minus under root of x square minus x plus 1. All right, it's very simple. Try this one. See what is the answer of this. Okay, so you're getting 1. No, there's one error. You have done one error. Limit is minus infinity, okay? Just recheck and then I'll tell you. All right, let me tell you what. See, if limit is minus infinity, then you can do two things. Either make it plus infinity by replacing x by minus x. So if you do so, then it's okay. You can use the previous method, which, well, I mean, you can just do it as you have done it right now. Or otherwise, if you're not doing that, then if you're after rationalizing, it is going to be x square plus x plus 1 minus x square minus x plus 1 divided by it will be under root of x square plus x plus 1 and plus of under root of x square minus x plus 1. Now see what is the error you have done. If you have take first of all, let's cancel these two, and that's it. Yeah, that's it. It is going to be 2x. So x, you need to 2x plus 2x only, right? That's it, 2x. Okay, while taking x common, okay, from these two terms, x square plus x plus 1, uh, you have taken x outside. Okay, in previous question it was all right if you have taken x outside, but in this, x, not x but mod of x will come. Why? In previous also mod of x will come, but x was positive, so mod of x is equal to plus x if x is positive. But in this case, you can see x is negative, it is approaching to minus infinity. So under root of x square is basically mod of x, and mod of x is plus 1 plus x when x is positive and minus x when x is negative. So that is the error you have done. After taking x square common, when you take x square common, then mod of x will come out, and under root of it will be 1 plus 1 upon x plus 1 upon x square. So in previous question I haven't mentioned this, okay, so that you do this error. And now because x is minus infinity, then you'll have to take x mod of x common, all right? Otherwise it will go wrong. Now this mod of x, what to do with this? This mod of x is going to be minus x, all right, because x is negative. So x is negative, then mod of x will be, just write mod of x is equal to minus x. That was the main thing in this question. So x and x will get cancelled. Then answer is going to be 2 upon minus of 1 plus 1. So it is going to be minus 1. Yes, we can take it outside, then with plus with the mod, okay, with mod. You can take it. In previous question, I haven't taken C. In the previous question, I have taken x only because x was positive. Even if you take mod of x, then mod of x will be x only, right? But in this case, it is. Got it? Okay. See, another way of doing this was, if you say by mistake you can do this error. So always make a rule by replacing x is equal to minus t in the original question only. If you do so, then limit will become t approaching to plus infinity, and then your question will become t square minus t plus 1 and minus under root of t square plus t plus 1. Down, you don't need to take care of that mod or mod and all. Just take t common, okay, after rationalizing. So if you rationalize it, it is going to be minus 2t in numerator divided by in denominator. So you can see this minus has already appeared here, okay? So that point has taken care of now. My t square minus t plus 1 and plus t square plus t plus 1. Got it? Now you take t common, so from denominator t will come outside. It is going to be under root of 1 minus 1 upon t plus 1 upon t square plus under root of 1 plus 1 upon t plus 1 upon t square and minus 2t. Then t and t will get cancelled and put t approaching to infinity. it is going to be minus 2 upon 1 plus 1. So answer is going to be minus 1. All right. So this is another way of doing it. I hope it is clear. Now let's do the another example. All right. So it is try this one. This limit x is approaching to infinity. This is a very good question. Yeah, you need to do rationalization only, because this is something infinity minus infinity and multiplied by an infinity only. It's infinity minus infinity into infinity. Okay, so what is this infinity minus infinity? You need to simplify first, and then the second term is already x raised to 2 by 3 only. Let me know if you need any hint. If you don't know how to start, then let me know. I'll give you one hint, and then you can simplify this. The main problem is to simplify this. That's it. Like we were rationalizing in case of a square root, we could easily rationalize it. And how to rationalize when it is 1 by 3 cube root. All right. Try it, Raghav. Hi, Shubhashri. Good evening. You were there in previous session also, huh? You just said hi. And where are you from, Shubhashri? Shubhashri. Yeah, you are new, but where are you from? Thank you, Subhashri. Thank you very much. Raghav, you're getting 1. Okay, let me check. I think it is 2 by 3, but let's check it. You know this formula a cube minus b cube is equal to a minus b into a square plus b square plus ab, right? If I replace a cube by a and b cube by b, then this is going to be a cube root of a minus cube root of b, or you can say replace a by cube root of a and b by cube root of b. This is going to be a raised to 2 by 3 plus b raised to 2 by 3. So this is a way to rationalize this. A raised to 1 by 3, b raised to 1 by 3. So if you have this term, you need to multiply it by this. A raised to 2 by 3 plus b raised to 2 by 3 plus a raised to 1 by 3, b raised to 1 by 3, okay? And if you do so, it will become a minus b. So in this, keep this term aside, x raised to 2 by 3, okay? Keep it separate. Subhashri, my class 3 p.m. and 6 p.m, okay? 2 sessions. Okay, so after rationalizing this, I'll get x, okay, I'll write first x plus 1 raised to 1 by 3. This is a raised to 1 by 3 minus, this is b raised to 1 by 3, all right, a raised to 1 by 3. Now I'll multiply and divide it by a raised to 2 by 3. Have you done this, Raghav? Plus x minus 1 raised to 2 by 3 and plus x plus 1 raised to 1 by 3 into x minus 1 raised to 1 by 3, all right, like this, divided by multiply and divide by the same expression. So it will be x plus 1 raised to 2 by 3 plus x minus 1 raised to 2 by 3 plus x plus 1. It might look lengthy, but yes, this is very useful, not only in limits, but this is useful in other chapters also, this formula, all right? So in this way we rationalize it. Now you can read this as a minus b, then a square plus b square plus ab. So it will be a cube plus b cube. So cube of this. So cube of this is going to be x plus 1. So it will be x plus 1 minus x minus 1, right? So it is going to be 2, right? It is going to be 2. This is of 12th only, na, Subhashri? Then it will be x plus 1 raised to 2 by 3. Okay, so now we need to take common. So I'll write this a step one more time, 2 by 3 and plus this term x plus 1 into x minus 1 whole raised to 1 by 3. Okay, like this. And this term is already there, x raised to 2 by 3. This x and x will get cancelled and you'll get 2x raised to 2 by 3 and take x common from denominator. So x raised to 2 by 3 will come outside, right? So x raised to 2 by 3 will come outside. It will be 1 plus 1 upon x raised to 2 by 3 plus 1 minus 1 upon x raised to 2 by 3. And from these two factors, this is x square minus 1 basically, right? So if you take x square outside, it will be x raised to 2 by 3. So it is going to be 1 minus 1 upon x square raised to 1 by 3, like this. Okay, now put the limit. This will get cancelled and x approaching to infinity, put the limit. So it is going to be 2 upon, this will become 1, this will become 1 and this will become 1. So 1 plus 1 plus 1. So answer is 2 by 3. Got it? Oh, you forgot one term. Okay. Vectors, it will take time, Subhashri, because I am doing calculus in one session and algebra in the other. Maybe next month. Okay. Now let's discuss 1 raised to infinity form. 1 raised to infinity form. Approaching to 1 raised to infinity, okay? So expression in the base, this base will be approaching to 1 and this power will approach to infinity. So say your expression is fx raised to gx, all right? Fx raised to gx. And for the given limit x raised to a, we need to calculate it. And it is known that fx, when x approaches to a, approaches to 1, and gx, when x approaches to a, approaches to infinity. All right, so this is 1 raised to infinity form. This is what we need to solve. All right, so first of all, let me tell you one thing, that this x1 plus x raised to 1 upon x, when x approaches to 0, this limit is equal to e. If you expand it binomially and put the limit, it is going to be this value, 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial and so on. Okay, so if you expand it binomially, its value comes out to be 1 plus 1 upon 1 factorial plus 1 upon 2 factorial and so on, and that value is nothing but e. Okay, so this is e, but these two numbers should be same. Okay, even if you write 1 plus f raised to 1 upon f, but f is approaching to 0. Okay, so it is same. This can be written as e. This can be written as third step of which, Raghav, previous problem? This one. 1, 2, 3. Which one? This one. Here you have doubt. Got it? All right. So I've just multiplied this, x plus 1, x minus 1, so x square minus 1, if you have any doubt in this. And then you can take x raised to 2 by 3 common from all three terms. Okay. Okay, so this was the main thing here. X plus 1 plus x raised to 1 upon x is e. Okay, we need to use it. And you will get this limit if you expand 1 plus x raised to 1 upon x binomially and put the limit. Binomially means 1 plus nx plus n into n minus 1 upon 2 factorial into x square and so on. Okay, so in that way you can factorize it. Next, put the limit, and it is going to be this series you will get. Okay, infinite series. The series you will get, and that series is basically the series of numbers is nothing but e. So this value approaches to e. That is the point. Now, how to use it here? See, fx raised to gx. Fx is approaching to 1. Okay, so what are we going to do? We'll write this 1 plus fx minus 1 like this. So you can see this number will be approaching to 0 now, because fx is approaching to 1, so fx minus 1 will be approaching to 0. So I've added 1 and subtracted 1. So as I told you here, that if f is approaching to 0, then it should be 1 plus f raised to 1 upon f. Then we can write it e, 1 plus f raised to 1 upon f. All right, it should not be g, it should not be any other function, it should be f1 upon f only. So here your f is, or your x which is approaching to 0 is f minus 1. Okay, this is your x. Anyways, let's write the limit x approaching to a. If I put this number in the power as well, 1 upon fx minus 1. Okay, I can put this. So because you have put this fx minus 1 in the power, so I have to multiply fx minus 1 also. Now this will adjust, and gx was already there, so gx was already there, so into gx. Now you can see this, everything is same. I have written this expression like this. Can you see this? Any problem? Have a look. This fx minus 1 will get cancelled, and this is nothing but fx only. Okay, the base is fx only, this whole thing is fx only. So this is fx raised to gx only, still it is fx raised to gx. Okay, so now you can see this fx minus 1 is approaching to 0, so 1 upon fx minus 1 is approaching to infinity. So it is same as 1 plus x raised to 1 upon x. So you can put the limit of this, its limit is e. All right, so this will become e. Okay, this will become e, and this will be remaining. You haven't found the limit of this. All right, so you need to write like this, fx minus 1 into gx, and x approaching to, limit will come here, so you need to calculate its limit. So this question can always be written in this form, and then you do it further. Now, which particular form is this? Now you need to calculate this, and after calculating, you put the value here. So e raised to something will be your answer. Suppose this limit is L. If limit of fx minus 1 into gx, which is now basically 0 into infinity form. And if you take gx to the denominator, it will become 0 by 0 form, okay? So ultimately, you are converting this to 0 by 0 form, okay? This, as suppose this limit is L, then answer is going to be e raised to L. That is your answer. So in this way. So this was the explanation, and I'll repeat it again. If you have fx raised to gx, okay, then how do you start? When x approaching to a, this is approaching to 1 and this is approaching to infinity, then immediately write this third step, okay? Skip this second, this is for your understanding. Write this third step. And what is your third step? Third step is writing it e raised to fx minus 1. This fx minus 1, so fx was approaching to 1. Now this is fx minus 1, so it will approach to 0 into this power. Power is gx, all right? So x is approaching to a. Now this is your question, all right? For example, I'll give you one example. Say it is 1 plus x sine x, all right? And here it is 1 upon sine inverse of x square, and x is approaching to 0, okay? 4 upon say. So what will we write? We'll write e raised to this whole thing is your fx, all right? This whole thing is your fx. You can check this is 1 plus 0. 1 plus 0 is 1. So this base is approaching to 1 and power is approaching to infinity. So it is 1 raised to infinity. So next step will be e raised to fx minus 1. So 1 plus x sine x minus 1 into this gx as it is. So 4 upon sine inverse of x square, right? Like this. We have reached to this step. Now this 1 and 1 will get cancelled. So this is going to be e raised to 4 times of x sine x, all right, divided by sine inverse of x square, all right? Now if you multiply and divide by x, then this sine x upon x is 1. Sine x upon x when x approaches to 0 is 1. And sine inverse of x upon x is also 1 when x is approaching to 0, right? This is also a standard form. I covered this. Which particular, what are you asking, Raghav? This example, 1 plus x sine x, this example, 1 plus x sine x raised to 4 upon sine inverse of x square, this particular, right? Okay, I'll explain this again. See, this was the question, okay? This was the question. So the first step was to check which particular form is this, okay? Now listen to this. First step was to check which particular form is this, okay? So what I did, first you put 0 in this. So if you put 0, this will be 0, right? X sine x will be 0. So it is 1 plus 0, 1 plus 0. So that means this base is approaching to 1. This whole thing is approaching to 1, okay? So I've got this 1, this is approaching to 1. And this power, because sine inverse 0 is 0, sine inverse 0 is 0. So when x approaches to 0, sine inverse of x square will approaching to 0. And 1 upon that or 4 upon that will be infinity. So this is approaching to infinity, okay? So I noticed that it is 1 raised to infinity form, okay? It is 1 raised to infinity form, this particular form, okay? Because this is 1 raised to infinity form, so I will write this step now, this step, okay? This step is writing e raised to fx minus 1 into gx. I've explained this, right? Write this form. So this whole thing is your fx. So I've written e raised to fx, this is your fx, minus 1 into gx. Okay, I've written this step. Then 1 and 1 will get cancelled, 1 and 1 will get cancelled. So only thing remaining is x sine x into 4 upon sine inverse of x square. All right. Now it will be 4 times of, okay, x sine x. So I've multiplied x sine x. This will be, I'll write this step, e raised to 4 times of x sine x upon sine inverse of x square. Now it is pretty simple because these are standard forms. Okay, so I'm going to use these two standard forms. If you have any confusion in standard forms, then please watch my 2 sessions on standard forms. Okay, I have discussed 6 standard forms in detail. Okay, in detail. You won't find any something like that in books. So go and watch those 2 standard videos on standard forms, and they will help you a lot. All right. Okay, so sine x, so I have multiplied and divided by x square so that this argument will become same, x square, x square. So sine inverse of x square upon x square will become 1, and sine x upon x is also 1. Okay, so it is going to be e raised to 4 only. That's it. Done. All right. That's it. Done. All right. So let's move to another example then. So now you try it. Okay. So now it is okay. Try this one. One minute. There's one change. Sorry. Yeah, perfect. Hello, Yuvraj. Subhashri, I don't have any idea about that. Raghav, please watch my previous two videos on a standard form. Okay, the name of the video is a standard form only. Okay, standard form. So standard form 1 and standard form 2. Watch those videos and it will help you a lot. I'm telling you, you won't get that stuff anywhere. Watch those videos. Okay, you watch anything else or not? No, but watch those two videos definitely. Okay, it will help you a lot in limits. Because if you don't know how to apply standard forms, then it will make questions lengthy always. The 6 standard forms I've discussed, I'll tell you. Sin x upon x. Not only this, but detailed. Sin x upon x is 1. Sin inverse x upon x approaching to 0 is 1. Tan x upon x approaching to 0 is also 1. Tan inverse x upon x approaching to 0 is also 1. And then e raised to x minus 1 upon x approaching to 0 is 1. And the last one, ln of 1 plus x upon x approaching to 0 is also 1. And whether it is 1 plus or 1 minus, I've discussed all these things. Okay, from which side it approaches to 1, because when you put greatest India functions, then it is required to know whether it is 1 plus or 1 minus. All right, so for such questions I've discussed all these things in detail. In one video I have discussed first 3, and in second video I've discussed next 3 with a lot of good examples. See, in this question, what you need to do is, first of all, you need to change 1 upon x, put 1 upon x is equal to t, okay? Or theta maybe. So it will become sine theta plus cos theta, okay? And it will be easy for you to, further doing, calculation wise, it will become easy. So whenever you see 1 upon x, just put a 1 upon x is equal to t. And because x is approaching to infinity, then t will approach to 0 plus only, okay? It won't be 0 minus, it will be only 0 plus. And obviously you can't take 0. So I'll write one step and then let's see if you are able to simplify it. Then this will become sine of t plus cos of t, right? And this numerator will become, see, if you club these two terms, then this is what? Ln of 1 plus 3 upon x, right? Ln a minus ln b. So 1 upon x, if you put 1 upon x is equal to t, it is going to be 1 upon ln of 1 plus 3t, all right? Like this. Yeah. T is approaching to 0. Now see, so if t is approaching to 0, this is approaching to 1, this is approaching to 1, and this is approaching to ln 1 is 0, so ln 1 is 0, so 1 upon 0 is infinity. So overall this is approaching to infinity. So now you can see it as 1 raised to infinity form. 1 raised to infinity form. Now try to do it. See if you're getting any answer. So which school were you in, Raghav? In Lucknow? DPS, all right. One DPS is an RK program, DPS RK program. Actually, Lucknow, okay. E raised to 1 by 3. All right. Let's see. Yeah, okay. I got it. Very nice. So e raised to, we'll write sine of t plus cos of t minus 1 multiplied to ln of 1 plus 3t. Okay. So as I have just told you, standard form, you can multiply and divide by 3t in this. All right. This will become 1 and this question will be remaining. So you can put the limit. If you're getting f into g, you're getting the limit of f, and g you need to calculate, then you can put the limit of f. Okay, just consider this as two questions. So now it will be remaining e raised to sine t plus cos t minus 1 divided by 3t. You can apply, yes, LH rule or standard also. So standard may you need to separate it sine t upon t, and this will become 2 sine square theta by 2. Okay, so it's okay, you apply LH rule in this. Okay, if you apply LH rule, so this is going to be cos t plus minus sine t divided by 3, and put t is equal to 0 in this, so it is going to be 1 minus 0. So e raised to 1 minus 0 is 1 upon 3. Yes, correct. Now you have got it correct. Good one. Now you try this one. Tan x upon x, greatest integer. I think you would be able to do it. Then 1 upon x square. All right. X is approaching to 0. Try this. This is greatest integer function. All right, very good, Vamsi and Raghav. Good, good. So basically, what this is not approaching to 1. This is actually exact 1, because tan x upon x, when x approaches to 0, this approaches to 1, and it is slightly more than 1. It is 1 plus. So when you take greatest integer of this, tan x upon x, and x is approaching to 0, it becomes exact 1. Exact 1. Okay. So this is exact 1, not approaching to, okay, to the power infinity. And if it is exact 1 to the power infinity, then this is not indeterminate form. This is 1 only, okay? 1 only. See, in the previous questions, see here I've written this tends to mean all these functions were approaching to 1. They were close to 1, they were not exact 1, okay? But in this particular example, now this base has become exact 1 when x is around 0, when x is close to 0 from right hand side or from left hand side, okay? This tan x upon x greatest integer will be exactly equal to 1. So that to the power anything, 1 raised to anything is 1 only, okay? So 1 raised to anything is 1, so it is 1 only. That's it. Simple. Okay? So this was the explanation. Now suppose I change it. If I give you another last example is this. So this is today's last example. Sin x upon x. Okay? Sin x upon x. And fractional part of this is fractional part whole raised to 1 upon tan square x. This x approaches to 0. A raised to minus 1. Okay, let's check. So basically fractional part of sin x upon x is sin x upon x minus greatest integer of sin x upon x, right? And you know sin x upon x, when x approaches to 0, this approaches to 1 but slightly less than 1, okay? X is greater than sin x. So its greatest integer will be 0. This is exact 0, right? Because this sin x upon x is slightly smaller than 1. So fractional part of sin x upon x is nothing but sin x upon x only, because sin x upon x is slightly less than 1, like you can assume 0.99. So fractional part of 0.99 is 0.99, right? So if x is less than 1, if x is between 0 and 1, then fractional part of x is x. So that is what is happening here. Sin x upon x fractional part is equal to sin x upon x. So that means there's no point of putting this fractional part. You can just remove it. So you can remove fractional part from this, and it is going to be sin x upon x raised to 1 upon tan square x. Now it is approaching to 1 and this is approaching to infinity, so 1 raised to infinity form. So e raised to, it is going to be sin x minus x upon x. If you do sin x upon x minus 1, it will be sin x minus x upon x multiplied to 1 upon tan square. Now before applying LH rule, first you need to simplify this. See, multiply and divide by x square. So it is going to be x cube here. I've multiplied and divided by x square, so that now I'll have two questions. One is this, other is this, okay? So this I know is standard form. This is 1. This will be 1. And this we will calculate using LH rule, all right? And fx into gx. So LH rule you can apply. So if you apply LH rule, let me calculate it here. Sin x minus x upon x cube If you apply LH rule, then this is going to be cos x minus 1 divided by 3x square, x approaching to 0, and further apply, because still it is 0 by 0 form, so further apply LH rule, and it is going to be now minus sin x upon 6x. So now the sin x upon x is 1, so it is going to be minus 1 upon 6. So that is the limit. Okay, so its limit, this limit of this function is minus 1 upon 6. Now put the limits of both the functions, minus 1 upon 6 into 1. So that is going to be e raised to minus 1 upon 6. Got it, Raghav? It is e raised to minus 1 upon 6. Alright guys, Vamsi, clear? So this was 1 raised to infinity form. I hope it is clear. So we'll continue tomorrow in determinate forms, and in that we'll cover 0 raised to 0, infinity raised to 0, and some more examples of 1 raised to infinity form. Okay guys, understood? Last problem. So thank you very much everyone. Like my videos if you're enjoying watching them, and use code Jeet1 if you want to take subscription on Plus, all right, to get instant 10% discount. All right, take care. Good night everyone.